but I'll just record through Zoom, MS Teams as well for the screen sharing. Got it. Thank you. Okay, so the recording should be starting, and I can continue. Thank you. Yeah, I'm doing Zoom notes so that can also be like a transcript that will listen to the audio, and based on that, it will also give you more insight to what I'll be covering. Okay, all right, so let's get back to our presentation. Thanks for that, Tandu. So you'll notice that with regards to operating systems, right, especially if I make an example of understanding where we're at currently, there's a lot of changes that's happening. So with regards to that, we have, artificial intelligence that steps in. Let me just put on my note. So we have, see if I can use this one here. So we have the age of intelligence, right? That's artificial intelligence. We have also operating systems that are evolving towards AI. And so the reason for that is, and I'm just circling that, is that a lot of things that's happening on the internet is made to assist with AI. So the processing, the way things work, the way the operating system have to handle things, that all changes. And that's why OpenELA in this case, which is a Linux operating system, are trying to have something called an intelligent assistant. And that is within the OpenELA ecosystem. Now, no other operating system out there exists that does that. So you have Windows. Windows have Microsoft Copilot, but Microsoft Copilot is an add-on from Office 365, which is not part of your Windows operating system. However, we do know there is your Android that has maybe Google, what's it called? I can't get to the name now. I know when you click on your phone, you have Google Gemini, right? So that's on Android because it belongs to Google. If you look at your iOS, you have Siri, right? Those are all mobile operating systems. Now, if you look at Windows, Windows have, I think Windows had something, there was a name, I can't get to the name now, but it had also something where you had an assistant. I can't get to the name now. Maybe you would know what the name is. And that would be how it actually, assisted, certain things. However, with OpenELA in Linux, because Linux don't have really a AI assistant, they have now introduced an intelligent assistant, right? And this is within OpenELA. And so that offers you as, students, AI-driven tools to help developers, office and management personnel. So that's basically operations and the management and those type of things of how the operating system works to help you with programming and system management. So what it does is it integrates a large language model capability into the operating system. So where you had your LLM or your large language model running separately, or you have to install it separately, OpenELA has allowed you to embed it into the operating system, which helps you to understand really how to navigate and do certain things. So that is a change of what happened with OpenELA. And that also helps you to enhance the operating system much better because it has its own built intelligence. Right. So that is about the introduction to what OpenELA is and where we're heading. Okay, let me get back to my slide. So in a way, and what you will learn in this particular course is you'll learn about OpenELA intelligence, or the AI as we call it. So we hear the word AI, which is artificial intelligence. Huawei changed it to OI, which is OpenELA intelligence, which is basically the operating system. And they removed the artificial word that you normally have in AI. And so you will learn in this particular introduction how to install and deploy OpenELA, the intelligence component, right, of OpenELA. And then also you'll learn how to, navigate and understand really what is the features of this intelligence, and the QA feature and the knowledge base. So what you'll normally get is, I'm just going to try to write here. So you get something called, I think this is a bit too small. Try to make it bigger. There's something called RAG, right? And RAG is basically just they call it random. I can't get the name. Something about I don't know if it's called RAG or am I confused with the term, but anyway. So there is a way of how you can build a knowledge base, right? And so the knowledge base is in a way in where you add your documents. So let's say documents, you can say media, pictures and things like that. Or you could add, system files, whatever you need to add, right? All of that can be added, into a knowledge base. And in our case, obviously, because we're dealing with Linux, it would mean that you would add maybe certain configuration operating system, right? That works in Linux on operating system, and that intelligence is stored to a local knowledge base, and that is how this whole LLM. So it will be the LLM plus the knowledge base. So let's call it, I'll just call it KB for knowledge base. So the element in the knowledge base will then give you the option to retrieve and search. So you would be able to search certain things, and that's basically what we're looking at. All right. So that's basically what we're going to look at. And as I said earlier, with regards to the knowledge base and how it works, you'll get to see how that can be set up. So again, what it is it? All right. So what is AI? I mean, we're going back to AI now. You've all have learned about AI. You've seen AI. I mean, if I have to make an example of what you know currently, you have ChatGPT. You have heard about. Just try to make this bigger for you. In my way. So you have ChatGPT. You have what else have you heard about? This Notebook LM. Let's make it blue. So we have ChatGPT, we have Notebook, LM. Those are tools you've heard about. DeepSeek, right? So these are all tools, right? And again, let's try to move this. No, I can't move it now because I'm just typing text on the screen here. So when you look at these tools, right? These are all artificial intelligence tools, right? And what they allow you to do is you basically get this whole AI that you see there that helps you to develop theories, methods, technologies, and many applications for simulating or extending our human intelligence. And what we mean by that is that we'll have this artificial world that has been trained with all our data, and based on that, it basically now allows us to think smarter. It gives us that assistance. It shouldn't replace us in many ways. So again, this was the first term. Now, a lot of things that you see in these slides, you have to start remembering or memorizing them because they will come into your quizzes and it might be in your mock exam at the end of this HCIA. So it is a lot of things that normally comes to play, especially with history, that you need to be prepared for. All right. So the first term that was coined by John McCarthy in 1956 is where he defined the subject as science and engineering of making intelligence machines, especially intelligent computer programs, right? So that's basically what we're trying to do with AI, right? AI is basically there to enable machines to think like people and make machines intelligent. Make them intelligent or make them seem intelligent. Because we get a lot of hallucinations also out there depending on how you use the model. So today AI has become an interdisciplinary course. Now, what do we mean by interdisciplinary? It means that in your discipline that you're in, finance, business, accounting, HR, IT, you name it, any discipline, it is integrated into any of those disciplines, right? And that's why it's called interdisciplinary course. And obviously it has that different range of fields that it's currently in. So when you look at this example here, you have, call it brain science, which is our neural brain, I believe. You have computer science, you have philosophy, which is the study of, theories that's out there, different theories. You have logic, right? You're right or wrong, one or zero, which is in binary. Those type of things. Linguistics, which is basically looking at language, different languages that it understands, so you can speak in Xhosa, Zulu, Afrikaans, English, any particular language out there. It's supposed to understand that, and that's basically how we've trained the model. Psychology. And I think that's scary because if you use AI to be your psychologist, then you really have to make sure that that model has been trained properly because it can give you the wrong advice. So that's also certain things that people basically look at when you look at AI. And then you also have our cognitive science, right? The way we do certain things, our feelings, our hands, the way we look at feel. So there's this talk about how AI has these five senses, or people want to have to create five senses, right? So you have us, we can see with our eyes, so that's vision. So you've noticed nowadays that you upload your images into these models, and then it looks at your image and it can actually, you know, interrogate where it is currently by looking at the picture. It can imagine the background if you upload a picture of yourself, and it looks at the background. It will know mainly maybe where you're at based on what it's been trained at. And so those are different things with regards to vision. But you also have vision that's involved into how cameras work. So you have a camera running, it's recording footage. That camera can interrogate that object and it can tell you basically in descriptive way what is that object doing, right? If it's a human, if it's a car, if it's a dog, it can do that. And that's the vision part of your, how we behave as humans. The feel, I don't think AI can feel yet, but you could, if you train certain senses to it, and that's how robotics work, it could feel and it could actually feel certain things. That's possible. Here, yes, obviously, because now I'm talking here, I've got Zoom notes running, we've got a transcript running, and later on it can listen to that transcript and listen to it, and it can actually give me a summary of what we spoke about today. And so that is basically the cognitive science, where AI really comes into play. I mean, if you talk about I think it's vision, feeling, hearing. What's the other thing? Smelling. I can't smell unless you have a smell sensor to a robot, and it will have to smell food and then tell you basically what kind of food it is. Those kind of things, right? So those are really where artificial intelligence really evolves around, right? And I mean, if you talk about, like I said, the brain science, is how our brain operates, how we think, how we do certain tasks, how we do certain things, right? We can do certain things. I mean, your memory expansion out from listening to me. At 5 minutes, your brain would have gotten tired of me talking. Because you would have so many other things happening in your brain, thinking, trying to get a concept of what I'm talking about, and you would basically just drift away, or you would be still in my class and listening to me now. And that is basically what's going on, about the brain science, where the AI would listen for hours and stay concentrated to your topic or you're discussing with it, and it will build a memory, right? The memory that you've noticed when you chat to an AI, it has a certain memory that it builds, and then next time you come back to the AI, it will remember what your previous conversation was, unless you clear the chat, right? So that is the brain science regarding a feature that's built into these models. So that is basically a whole introduction to really what is artificial intelligence, and where we're at. Okay, so there is a hierarchy of AI, and it's basically just where it's at, and in this case, this particular course, right? So we start at the bottom, right? So when we look at infrastructure, right? So we have infrastructure, which is the hardware, the computing capability, and big data, right? That's infrastructure. The OS that we're talking about here now is OpenELA and many other operating systems. And then you have machine learning, right? And deep learning. And those are algorithms that we use to train the models, right? Machine learning, we have a algorithm that we run, and we're testing and we're testing and we're training the model, we do inference and all that stuff. And then obviously deep learning is looking at the neural network of how things come together and making decisions, right? And that's also large data sets that you go through. And obviously, this is where it's directing to. You either have an AI model that's a computer vision, or it does speech processing, or it does natural language processing, or it does decision making, or it's used for big data and statistical analysis. Now, that direction is basically independent models, right? It could be computer vision or speech, or you could have a model that can do all of that. And that's where you hear the term agents, right? We have this multiple agents that you hear nowadays, where a model can do many things. It's not that the model can do many things because it uses different ways of learning and attaching and using other particular learning ways of how a model works. So speech processing is what we use daily, and that's basically how it's going to listen to my speech now, and it's going to create a kind of summary of the transcript. And then when you listen or you watch the transcript or the summary it's giving me, you'll listen that it actually recorded what I said and how it's actually processing it. And then computer vision is basically where I'm talking about video cameras or any particular camera that's looking at a video footage and then it needs to analyze it and make sense of a snapshot or an image. You also have computer vision where it uses your camera live, and then the model will look at you or your fingers and it will train itself. And that's how you have some of these models that understands, um, 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 let's call it sign language, all right? So you look at a model, you train it sign language, fingers, and how you move the fingers, and later on it can interpret that and understand that particular way of things. And then you have natural language processing, which again is basically just listening to you and processing that information naturally. And that's basically the NLP, which listens to voice and then processes it. And then obviously decision making, it's probably any particular system that's out there, and then a big data analysis. So again, when you look at the technology, you have image recognition, which is also a part of a model, image recognition. That's common with Google. If you look at, you go on, if you have an Android phone and you take an image and you share it to your Google image, Google will analyze that image for you and it will tell you basically, is there any similarity images on the internet? Or it will tell you basically what is the description of that image. And that is image recognition. Many models has that, and that's basically the NLP feature, or even a computer vision, depending on how it's trained. Image processing, and that's just what I mean now. You get the recognition and you get the processing. And then you also have video recognition, which is mainly where the vision probably comes into play, and then speech recognition as well. Semantic understanding is a way of how it maybe searches through key things. So it looks at audio, video, and data, and it's trying to analyze that and do a semantic understanding of what's happening in that particular aspect, right? So it could be you need to understand really um, a snapshot of of a video, right? You upload a 30-second video, and then the AI now needs to integrate and find out really what's going on there. And you'll notice on YouTube, YouTube basically sees these snapshots of videos that you watch, and it basically creates this whole search algorithm. So next time you want to watch that, it has a snapshot of understanding your search criteria. It indexes certain things, and that is basically the semantic understanding. You also have text to speech, and again, that is when you have the text and it generates speech and it creates these speech models where it actually talks back to you. Uh, a famous thing of that is Google Notebook LM. There's a way of how you can, listen to an audio and then you actually talk, and it gets that text and it basically converts to speech. So that's one way. And then obviously machine translation is where it listens to our particular language and then it translates it into an understandable way of how it can process that information. Speech understanding, same thing as what I'm talking about now. Recording your transcripts and those type of things. That's basically how it works. And then you have sentiment analysis, which basically looks at different images or video feeds or audio feeds, and it analyzes those things in sentiment ways. And then the knowledge graph is basically building a knowledge graph of what you go through. And those are different technologies of how AI really have evolved and how it actually works in a way. And so in many cases, when you look at these three could belong to one particular model, right? It can do image recognition, image processing, and video recognition. And that could be that could be maybe a certain model that can do that. But you would have a model that maybe can't do speech recognition, and it would be a certain other model that's out there. So it's basically on each technologies of these that we have this whole notion of agents that really ties in and try to understand certain things. And so the industries that uses these are autonomous driving. So we have cars that drives on their own, and they have to use the vision, the computer vision part, because autonomous driving works with computer vision. If the model have a camera and it needs to look on the road and it has to look at different objects, it will be used for autonomous driving. And obviously, without computer vision, it won't be able to know where it's at. Robots again could be the same thing, but robots can also do speech processing or understand decision making. Intelligent healthcare, that is where you have all these different things happening. Intelligence finance, and that's obviously for making decisions about finance. Smart home, also one of the technologies. AR and augmented reality, which is AR, and in VR, which is virtual reality. And you have the unmanned aerial vehicle, which basically is a drone. That's a big term for drone. So this is basically a drone, right? Unmanned aerial vehicle is called a drone. And you have many drones that's out there that's even been used in the war. You've noticed these drones that they use to attack, during the war. Those are basically controlled, either using machine learning. You've heard the whole talk about what happened in America, where they use Claude to attack another country. I think it's in Iran, and they got data from this model, trained, the information that they received from the model, and then tried to make sense, and then obviously coordinated the attack using that Claude model. So those are also certain things where AI is being used. And I mean, I'm not saying it's a bad thing or good thing, but it's just showing you the capabilities of what AI can do and achieve. And so, on top of this, you have the perception analysis, understanding and thinking, and decision making and interaction. And that is basically how AI operates and where it's currently at, with regards to understanding really about AI and where we're at currently. Okay, I've been talking for just checking the time. Right, so let's see, it's 4 o'clock, but let's continue. Because I like to give you just 5-minute breaks in between so you can just recap. Okay, so diverse computing power and versatile support, right? So these are just the capabilities of where OpenELA fits in, right? With regards to where it fits in into this whole sphere, right? So we have AI for OS or operating systems, which is basically just this whole tool that I talked about, the domain knowledge and QA, scenario specific optimization, and the efficient intelligence operations and management. And so again, you'll notice that here's the technology. So a customer relationship management system, or ERP system, and many of these different technologies that you get, right? They revolve around these different multiple applications. And then OS for AI. So you have AI for OS and you have OS for AI, which is basically just understanding how you can use the operating system and to do certain things. And again, the applications that is being used is in a server, that's in the cloud, it's on edge, which is close to your network, in a way. And then you have embedded systems like your little ESP32 devices, your Raspberry Pi, your Arduinos. Those particular embedded devices, they can also run these particular things. So it tells you in a nutshell that OpenELA and the capabilities of this operating system is diverse. It can handle all these different applications. Unlike Windows. Windows, you can't run Windows on a Raspberry Pi. It's not there yet. You have the Windows DOS, but I mean, you don't want to use that way. If you look at any other operating system out there, yes, you can run Ubuntu on a Raspberry Pi. You can run many other operating systems. But again, if you look at the diverse way of how OpenELA is being set out, it can do all these 4 different devices. And these are just the processing, the processing architectures that it can run on. ARM. So ARM is basically this whole way of where you have your Raspberry Pi and they run on an ARM processor. x86 is your normal processor, which you run on your normal laptop. For instance, your Intel processor. RISC-V is also a type of processor. And then you have SW64, which is more Chinese, I think, brand, and Long Arcs, which is also a Chinese server brand. But that just shows you basically it's multiple compatible to run on any particular infrastructure on the server side and so forth. And if you look at on the right hand side here, you can see that it runs on NVIDIA, the Ascent, which is basically Huawei's graphics card and CPU. And then there's other particular other solutions also out there as part of the ecosystem. So what is AI for OS? It's basically just AI that makes OpenELA more intelligent. So it makes this operating system more intelligent, and then using foundation models to basically create this whole knowledge base. So it's easy for you to analyze a problem on your Linux operating system. So it's basically just you can use it through the web. So there's a web feature of it, and you can do it through the shell, which is command line driven. And there's an agent framework, which is the engine, and then the knowledge base, which is RAG. There's the word I was looking for earlier. Retrieval augmented generation. So that is the knowledge base I was referring earlier to, which I couldn't pronounce, but there is retrieval augmented generation. And that's basically how it builds a knowledge base. So for instance, if you had to, let me just clear the screen. If you had to upload under this model, let's say 100 documents, right? So you upload 100 documents or five, it's called 100 documents, but yeah, let's say 100 documents. And so these 100 documents they upload here, what will happen is that this machine here, the document parsing engine, which is this one here, will then look at the documents, create it into different, call it, not snapshots, there's another word for it. It's called, what you do when you break documents into can't get to the name now. But it breaks it into smaller bits, right? To be in order to analyze the text. So in a way, and you can upload a large hybrid of documents, and then what will happen is that it will, break that into small snapshots or snippets in a way, in order to understand what's going on. So it creates this document parsing engine, and that basically then creates the RAG where you can look at a document, ask a question, and it will look at the history of where the document is and it will retrieve it for you, almost like it's referencing the document. So it won't generate fake or hallucinate. It will look at that existing document where your question relates to, and will find a document, and that's basically how RAG works. And that is basically the document parsing. I'll get to the name term later on if I get it out of my head, but there's a way I can't think about now. Unless you guys can put it in the chat if you recall what I mean by that. And obviously the agent framework is basically just how this whole agent works in that. And so again, OpenELA then sits underneath that whole framework, and it uses the intelligent features of it in order to basically create this whole helpful AI for the operating system. I'll get to the term later on. I can't get to the name now. What it's called when you break it into snippets, or you're passing the information into smaller things. Okay, let's clear that. So how it works and how this whole intelligence Q&A works is that you can access it via the web entry. So you can search via the web on the particular thing on your local operating system, and you can do the shell entry as well. You can ask question in the shell on your operating system, similar to how you would use ChatGPT or any of those things. And then how it works, it provides a workflow scheduling, all right? It creates a task recommendation, and it uses the RAG, which is retrieval augmented, what was the word? Retrieval augmented generation, all right? And then there's a corpus governance. Now, what is corpus governance? It means that it basically looks at the text that has been sent and trained or retrieved, and it creates this governance model that it won't obviously create this whole hallucination. Whatever you ask, it's in the knowledge base and it's in that particular aspect of that data that's there on the model. And that's basically the governance around it. And that's very important because you don't want to upload information and then it's giving you false information in many cases. So how does it help, right? It helps common users like us, I'm also a common user, to learn more about OpenELA and how to, for example, in this case here, how to port applications to OpenELA. So those will be basically certain applications that you need to run OpenELA. It also helps developers to be more familiar with the contribution process and key features of project management. And it also helps your operations and management personnel to understand system management methods and how to solve common problems. So when you struggle on Linux, in this case, you don't have to go to ChatGPT or you have to go to Claude or DeepSeek. Everything is inside the operating system, and that's basically how this whole intelligent system works in many cases. Okay, so there's also the functions of it, right? And again, I've touched on that earlier, but I mean, just to go in detail with it, the RAG part, right, is basically just taking the whole RAG combination and understanding really how it can help you addressing the, certain gaps in understanding about Linux because there might be certain things you want to learn. And so RAG again helps that, to help you and developers or even enterprises to do that. So again, what it does is it has semantic interface management. So it has this whole interface that you can see. And you'll see when we do the demonstration or how you have to set it up, what the interface looks like. And I'll show you that in the lab guide as well. You have the intelligent orchestration, the large language model management, and then the corpus governance that I spoke about now just recently. And again, how this basically works is there's a plugin for semantic plugin generation. There's the workflow. There's the model itself, and then there's the document parsing in RAG, which is the corpus governance. And those four features is basically just how this whole OpenEL intelligence work and the functions of it as well. So where does it fit in, right? If you basically run your operating system, this intelligence at the back end, right, without you noticing, it will collect performance data. It will analyze your system's performance, optimize the system performance, and it interacts with OpenEL intelligence using natural languages. So when you run the operating system, it looks at all these information that it gets. Remember, when you run an operating system, the operating system needs to run and talk to many processes. There's many things that happen in the backend that you are not aware of. So for instance, looking at collecting system information collection, right? When you open up your task manager, in Windows, you see a lot of services running there and a lot of tasks. So sometimes you don't really understand what all these tasks mean and what are they there for, right? And many of these tasks you might need to use, or you might need to end the task if your PC is slow and it's not responding in many cases. So that information that's being collected, an AI agent would allow you to do the smarter decision and know exactly what's causing memory overhead, what's causing the PC to be slow. Where we would know that not from looking at the computer itself, right? And that's where the system information collection really comes into play. The other thing also that it does is that it uses this profiling collection or perf EBF, which is basically just the network information, and it processes that as well. It collects the CPU memory and your input output or the network information, and it looks at the language runtime information connection, and all of that gets filtered, cleansed, and compressed and upload and all that things. It's part of the metric collection, and that's basically how it achieves the system to perform better, right? So it looks at all that information, that metrics, and it tries to whatever you run on your Linux operating system. In many cases, it will try to create that awareness how the system should work. So it then builds this expert knowledge base, the performance analysis, and all those use cases that you get and it tries to improve the system. And that's basically where this whole intelligent functions come into play. So it gets all that information and it basically allows the operating system to be run smoother and faster. Because what if you have a database running like MySQL or a web server like Nginx, or even a caching service like Redis? You have to now create that awareness that those are the applications running. And in the operating system, getting that metrics will have to make the smarter decision. And that's basically what it allows operating systems in many cases to do. So there's also the intelligent diagnosis. So what it's going to do is it basically goes through whatever's running on your operating system, right? So it does some sort of inspection, and it checks any abnormal abnormalities. And then also it looks at whatever IP addresses is running on the operating system, or that's basically part of the system itself. The CPU and memory usage, it looks at all those things, right? And then it creates that whole kind of feature where it basically try to basically try to resolve the incident, but also trying to make sure the system runs and not actually bring the system down. So it creates a cool demarcation where it actually tries to take that knowledge that it got from the abnormal system or normal process and basically just creates an inspection result, and it tells you what's the metrics or what's the cause of that problem. And then the detection agent then performs that profiling location and then try to find out what is the problem, right? Is it the stack? Is it the system time? Or is it performance metrics that's related to that cause? And that's the whole, almost like when you go to a doctor or to a clinic, you maybe have flu, but now you think you have flu, but you might just have a cold. So now you think that you have it worse, but you might just have a light cold. And so a doctor normally would know what is the status by looking at your health, putting stuff in your mouth or trying to look in your eyes or look in your ears, whatever they have, how they've been trained to do. And so the same concept with this would be that it looks at the user input, inspects the health status of the current node, and if there's any abnormality or abnormal process that's running there, then basically what it will do is it will basically go through those checks. So the framework here, in this case here, it checks the inspection, it checks the list, right? What could be, the abnormal list. I'm going to try to zoom in here so you can just see what I mean. So it looks at the list, what's the common things that could be the problem. And then from there, it goes into the states, which obviously looks at, understanding what is this, right? And then it creates the demarcation where it isolates the incident, right? And it goes into the demarcation agent, which then looks at the abnormality, outputs the top three metrics of the root cause. So it looks at the logs and anything that's running on, that particular service. And then it plots out the top three metrics, which could be the root cause of that problem, right? Then from there, after that, it goes and it does the three checks. So it checks either one, it checks number two, it checks three. So it tries to find what is the root cause of that. And then from there, it goes into the intent understanding or the location where it is. From there, the detection agent then kicks in and it's trying to really find out what could be the problem. And then that's how it gives you the report, where it basically tells you this could be the problem on that operating system. So if the web server, that you're running on the server is not responding, you might think, oh, maybe there might be I configured something and I did it wrong. The agent will now understand from whatever happened in the metrics and the values, what could be the root cause. So in that case, that's the open ELA intelligence, and then you have the agents that basically runs also on that operating system, and that is basically just how this whole agent works. It's quite interesting how it actually operates in that sense. So then you have the intelligent functions, which is now the container image. Now, a container image, if you're not aware, is like a container that runs a lightweight of the operating system, right? It's not really a whole operating system. It just runs a container. And that allows it to run on any particular device because it runs the needed dependencies. So again, they basically have stored this on Docker Hub. So it's a Docker image, and you can normally manually pull and run these container images. So these are the SDK layer, which is a software development layer, which encapsulates certain libraries. So these are CUDA and CAN is basically just two frameworks. So CUDA is more for NVIDIA graphics cards, and CAN is more for ASIC or Huawei type of CPUs and CPUs. So these are just the different hardware resource it runs. And then you have certain inference training frameworks that accommodates like TensorFlow, which is basically how you train a model, PyTorch, which runs on Python, and there's many other frameworks that you get. And then again, you then have the the large language models, again that encapsulate certain models, like maybe they run Llama, which is open source, Llama 2, 7 billion in this case the model, and then you have Chet LM2, which is 13 billion. Now, based on these containers that's running here, it all depends on the processing that can run those containers. So you have to make sure that when you run the container that you have the capable, let's call it hardware processing. So when you look at this here, you'll notice this is just where it's stored, right? This is just where the containers are stored, and this is just the image names of those containers and OpenELO repository where it's currently stored. So there's CAN, there's the LLM server, there's MLflow, there's a normal LLM, but you can see there's the open source models like Llama, and I don't know what's Fast Chat, that's also another model. And then there's obviously TensorFlow, PyTorch, and then CUDA. So these are the different models that's available as container images. All right, so those are the introduction to what is OpenELA and intelligence. And now it's basically just how you basically have to understand how this works. Okay, so this example that you see at the screenshot here is basically just the operating system that have installed the agent already, the OpenELA intelligence already. So this is what you will see normally. You maybe ask a question like that. To manage OpenELA using commands, what do I need to do? And so this is basically what the output would be on that model. So you'll notice that the way they've trained this model, it's like a program model. It's like you're looking at Claude because they've trained it in a way that it understands your OpenELA operating system. So it understands packet management, what you need to do, update all packages, search for packages, or checks updates. That's an example of how you would prompt. Now, obviously, you can prompt different, but we're not doing prompt engineering now. But you can also prompt differently with regards to that. There's another example. Maybe you want to understand OpenELA better. So here you could ask the question, I'm a beginner with no prior experience. Please provide a learning path for OpenELA. And so again, that's how the model will reply to you, right? Based on what you ask, it will tell you to build a structured learning path from OpenELA. You need to understand the introduction to OpenELA, the core learning part for beginners, what you need to understand. It gives you the commands and syntax as well. It tells you what tutorials you can go look at, and it shows you basically just how you can install it and so forth. So those are certain prompts. Okay, so I'm going to stop there, and then I'm going to take a 5-minute break, and then I'm just going to show you the lab guide of what you would have to go through, how to set up this agent, because that is the introduction to where we're at now and what is this course about using the OpenELA intelligence. So there is a question there, true and false. So the question is, OpenELA Intelligence Platform currently supports two entries, web entry and intelligent shell entry. Is that true or false? What's your answer? You can put it in the chat. I'm gonna stop sharing and we can just take a 5-minute break. I thought you guys have access to these slides on the platform, but I'll say it on the WhatsApp group. I thought you guys have access to it. But let's take the 5-minute break. Do you guys know the answer? The answer is true from that slide, because remember what I said, it supports web entry and shell entry, and that's the two features of the OpenELA intelligence. Okay, Right, so starting now at 16:19, we can take a 5-minute break, and then I think it's 6:20 now, so we can start 25. So we'll start 16:25 if my time is correct. We'll start again. Thank you. All right, let's see. Okay. All right, we're back. So let me see with you the document, which is the guide, which I'm sure you guys should have access to, but I'll just double check. I'm trying to log into the system now as well, just to see what permissions you have access to. But if Thando can just confirm later with me, then I'll check that. Okay. So what you'll notice is that this lab guide is a Word document, and it's the lab guide HCIA Open Era. All right, it is version 2.0. So when you see these versions, that means that that's the latest version. If you see 1.0, that means you have the wrong guide and you might be informed about the project status or the lab. So keep in mind that we have Open Era 2.0. All right, so let me go through the first part of it. So what you'll notice is that with regards to this, there's different labs, right? There's up to 8 labs, right? The first lab will be how to deploy OpenELA Intelligent, right? And again, like I said, in our next session, I'll demonstrate that to you, where you can see basically just how how it's done and installed. And basically that will allow you to understand basically how to do it. Because after you've gone through all the courses, then you can then do that independently. I don't want you to do it yet, but I'm sure that because I know that the Huawei platform should have it also enabled in the quizzes section or the mock exam section or the course section. I'm not 100% sure, but it should be there as well. So that's the first lab. Then the second lab is basically just how to install OpenELA using a normal virtual machine on a local PC, and then install OpenELA on the VM. So we'll look at the likes of, I think an example here, I would say, um, I will look at maybe Oracle VirtualBox. So you have VirtualBox. You get VMware as well, Player, and then you have make this now bigger. I should have stopped it. So Virtual's VMware Player, and there's other things as well. Let me just make this smaller. So Oracle VirtualBox VMware Player. I think those are the two things I'll probably start off if you need to understand really how to install OpenEL on a VM. And that depends on your type of operating system that you're running it on. So that's the one thing. Then lab 3 again will look at how to do the command lines. So those are the basic bash commands that you get in OpenEL and so forth, right? How to execute certain files, how to access the directory, and many other things that's also there. And then you have lab 4, which basically just shows you how to use the OpenEL text editor. So there you will do something called Vim. So how that works is you would have, for instance, I'm going to open up a terminal quickly. So you have this terminal that I just have open here. So this is just an example of a terminal, right? And so what you would do is you would use the Vim editor and you go into this particular thing. Now, Vim allows you to do certain commands and edits, right? And when you're done, if you see at the bottom, try to make this bigger. I just moved it out of the way now. Let's make this small again. No, I think I made it too big. That's why I just out. Let me just go out. So if I go back into Vim, let me just make the screen first bigger for you. And then just type Vim. So you can see here. So now what it allows you to do is you would have to type Q to quit, as you saw now, but you type semicolon or the colon and then quit. And then if you want to save it, you type WQ. So we'll learn that commands again later on. But that's basically the tool that you will be using in OpenELA to edit certain things. So that is basically Vim, right? That's lab 4. So we'll get to that. Then lab 5 again describes OpenELA configuration. And those are basically just how you manage certain things. So you'll learn about installing software using the DNF command, which is basically similar to how you would install certain things. Okay, Tandu, yes, your hand is up.
So the
Yes.
screen is frozen. There's a
Is
person in
it?
the chat who's saying the screen is frozen.
Can
Yes,
anybody see? Is it frozen? Let me just reshare again. And now, still frozen?
we're all good, sir. Thank you.
Oh, good. Thanks for that. When did it start freezing? Just checking when you guys missed and because I was still on the slide. Yeah. Okay. Okay. So when you look at DNF, DNF is basically just a way of how you install the packages. So we'll look at in using that in Lab 5, where you understand how you run certain jobs and how you use systemctl. And systemctl is basically just how you start processes and running certain processes. And then Lab 6 will be where you understand storage and network configuration, where you learn about drive partition, how to partition drives on your virtual machine in that virtual open either Oracle VirtualBox or VMware. Or if you really want to go bare metal, you can install OpenELA on your on a USB memory stick and you run it alongside your Windows. That's also another way. Or you just partition your drive and then you can install it separately. But those are things you can look at many ways. So then again, Lab 6 will look at how you drive mount the partition, how you check your logic volume management and network configuration. And then Lab 7 again is basic shell scripting. So that's how you learn about scripting, how you create a sequence of commands. And then basically it goes through that shell scripting. Normally shell scripts ends with .sh. So you'll go through that whole sequence of commands to understand really how you do scripting and so forth. And then Lab 8 then describes the basic usage of ISULA, which again is a way of how you can run certain operating systems. I think containers and storage configuration with ISULA containers. So this is Huawei's version of your Docker container, your Podman container, which you get in Red Hat normally, and then you have other type of containers. So ISULA is probably just an installation of how you can use that on site your Linux operating system and using persistent storage. Persistent storage means if the operating system stops or reboots, the storage is still present, although it's not real storage. It has a persistent storage, so it won't delete the storage. It's like your normal hard drive where you store information. When you switch your PC off, you switch it on, tomorrow the storage will still be there present. So that is persistent storage. And another term for it is called non-persistent storage, which means your memory stick, if you put your everything on your flash drive, you format it, it's gone, right? So that is non-persistent, so it's not always there. So that's the background. That's the information of the labs. The background again is basically just you need to understand computer operating system and hardware. It's not really a difficult course, but you learn about many other things. Like I said, VMware Workstation or Oracle VirtualBox, as I said, which is a recommended software. Um, and obviously how to install it, and so forth. So those are things we'll go through, right? How to create a VM, which is the OpenELA VM, how to connect to the internet, log in via SSH. As you saw now, an example here that I showed you previously, this is me logging into a system that's on SSH. So if I go into any of, maybe I go into this one, I'm basically SSH into a node or a machine, right? And that is what you'll learn basically, using, the setup and what we're going to go through. And also, again, understanding how to bridge the virtual machine network cards with a physical network card of the PC. So that's network bridging. So we'll go through that. Or method 2, where you create two network cards, virtual network cards for the virtual machine. One that will be using network address translation mode, meaning it has its own internal IP, and when it goes to the internet, it has like a public IP, and that is NAT. Or you use the host only mode, which means that it's not exposed to the internet. And then method 2 is basically just in this document where you need to configure your own network on your own. So that's actually, this would be method 3. Oh no, it's method 2 because this is the one that we'll go through in this lab in detail. The normal method is basically this one here, which is like If I run an operating system or virtual machine virtually, it will use my laptop's network card in order to give the virtual machine access to the internet. And that is basically how it works. So the first lab, just to get to that, which is introduction. This is basically just where you will now use this whole practical AI platform to really understand OpenELA much better. So when you have your OpenELA installed on the virtual box, you have to change your permission to root, right? So what it means is that if you're not root, I'm going to try to just make this bigger. Uh, yeah. So if you, the root user, root means you're the administrator. You can do many other things with root. So it's very important that if you say the word sudo, it means change ownership to root, then you basically now will do the permissions as root. So you'll notice here in this example here, you'll see OpenELA here. It says OpenELA at VBox, and there's this dollar sign there. That means you're a normal user. You're not root, right? You don't have the root permission. But when you change to root, in this case here, you'll notice now you have a hash symbol, right? And that means you now have full privilege access to your operating system. So you now basically root user. And so that means that you tend to basically can do, you're very dangerous if you break your operating system because you root, right? You're the owner of your operating system. Whereas if you have the dollar sign, you might have least privileges and you might not be able to do certain things that a root user can use. So those are the two ways to understanding where you're at. Even when you're basically building and installing certain things, it's very important that you really look at the dollar sign or the hash symbol. And then you'll know what permissions do you have as a user on the operating system. So here again, by being root, I basically, you can notice here that they say git clone. Now, git clone is a normal command that you use for GitHub or for Git, the tool Git. And in this case here, Huawei have stored this on gite.com. It's not GitHub or GitLab. They use Gite. So it's not a wrong spelling here. Just the Chinese has also their own a repository of where information is stored. So they use Gite. The other term you would normally you would have seen GitLab or you would have seen github.com. So they use Git and then that's where you will find the OpenELA Copilot framework, and that's where you get it from. Okay, so you have to run that command. So I advise you do this on a virtual machine that has OpenELA because it works just on OpenELA, not on any other operating system. If you run this on Ubuntu, Linux, or any of that, it won't do the same justice to you. So you run that command, it downloads that, and you'll get, if you're done with the download, you just use the command ls for list. It lists the directory and you'll see OpenELA Copilot there extracted or downloaded, sorry, not extracted. And then after you've downloaded that, the next thing you now need to do is you can cd into the OpenELA framework. So if you notice here, it still needs to be extracted, right? Because again, that's just it might be a folder, it might be a zip file, but I think in this case, it's a folder, the way it's downloaded, right? And again, when you look at that, because it's a folder, because you didn't download as a zip or you download it as a repository. So what it does is Git then actually extracts it automatically for you into a folder. So you'll see the folder and it will be labeled blue because it basically says it's a new folder or your permissions as root. And so again, you then cd into the folder, which is OpenELA Copilot Framework, into deploy scripts. You go into that folder, deploy scripts, and this is where you need to change the ownership of that folder, right? Because if you don't change the ownership, it means that you won't be able to deploy, um, this file, right? So while we're doing this is CMod means change ownership, right? So it's change and modification. And R means recursive. So we'll learn that later on when we get to know Linux much better. And then the plus and the X means executable. So when you look at, if you look at in many cases attributes, you have read, write, execute. Those are the three attributes, right? So read is R, write is W, X is execute, meaning you can do both, all three executions, right? You can do a lot of things. So the X means that you want this particular script folder to have executable permissions. And you're basically putting a star there to say that all files in this folder scripts will have that rights and permissions that you set there. Okay, I did something there. So that is the command you would run if you want to have that permissions. Now recursive means you basically want to go into the folder and the command should actually have that permission to go into each file. So there's the command at the bottom. And if you look at this here, if I make it bigger for you, if I list this here, you'll notice that those are the scripts that's there, right? There's a bunch of scripts. There's one-click deploy, which is script 0. There's one that says check environment. There's one that says install tools. One that says install Ulama, deploy DeepSeek, deploy embedding, install databases, install AuthHub. And then 8 is install OpenELA Copilot, and the other is other script. And then there's a deploy sh, which I think would install all of them together, depending on the script. So again, by running that deploy sh script, you say bash deploy because you're now in the terminal and you still root. And then it goes into this whole language selection. It checks your language. So you would have either English, so you'll choose English, you'll choose 1. And then you go through deployment main menu, right? After you type 1, you go through the manual step-by-step deployment. And basically, that's basically how it goes through the sequence, right? After you select 1, you will execute the script, install Kubernetes, K3s, and Helm, and install LAM. And this is basically the step that you'll have to go through, right? And that's the manual step-by-step deployment. And after that's done, which is type 1, 2, and 3 in a sequence, let me just try to zoom out a bit. After that's done, you basically execute and you do all of that steps. So that will be the script that will run, right? Going through these scripts. And in each option that you select there, it goes and installs based on what that script is needed, right? So it goes through this whole process, installs Helm, K3s, which is lightweight Kubernetes. It installs Ulama, which is your local language model that runs, the language model that actually Ulama is the tool that runs your language models. And you'll notice here when you use the kubectl. So we'll get through this again. I'll give you some introduction course to Kubernetes, the lightweight Kubernetes, that you understand really how this works. When you use kubectl, you actually see how the process is running or the processes. And when you use Ulama, again, we'll see the model that was maybe pulled down. So there's a model that's BGE-M3. That's the size of it, and that just shows you basically that model will work with your local language model, Ulama. And then before deploying the database, you may basically have to set kubeconfig. So this command here is basically just giving kubeconfig permissions to run as on the root user to execute certain things. And then you install the database and AuthHub in a sequence. This is other things that we'll go through. And then after that's done, then you have your OpenELA intelligence running. And that is what you will see basically as your local AI on your Linux. So it will tell you then, hi, I'm OpenELA Intelligence. I'm happy to be of service. And those are the certain things it can do and suggestions. And that is basically just the first start of how you use that. Again, this is the cloud, but I'm not going to get to the cloud now because we probably not going to get to the Huawei cloud, but I'll get to that again at this stage. But that is the introduction to OpenELA intelligence and the steps that you'll go through to get this working. Because you just do this once, but you need to make sure that you put the right IP address of your particular VM. Otherwise, it will obviously give you an error if it doesn't use the same host IP address for this particular reason, and a certain port that it's also running with on. And so that is the lens and steps you have to go through to run this local model on your PC. So it's first doing the check of the environment check script, then install lightweight Kubernetes 3 and Helm, then install Ulama, and then after that deploy either DeepSeek model, deploy embedding model, and then install the database, AuthHub, and then install OpenELA Copilot, and then that's the step. But each step goes through a step-by-step process in that sense. Right. So that is the introduction to OpenELA, and that you'll see that you're just not learning Linux, you're learning other things also, that how this model really is installed and how it behaves, and the length of the configurations that you have to go through to get this model working on your OpenELA. Okay, I will stop there today because there's a lot that we'll go through here. You do have access. Oh, it's embedded as a PDF. Now I understand why I don't have access to it. Yeah. Thanks for that, Tando. So it's a PDF in not in presentation mode, but I think there's a zip file that should have the presentations there. I'll just double check and then I'll share that with you guys. So students, that is it from me. Sorry, I spent it an hour and 35, well, yeah, minutes or so. But I think our next session will be more practical, where I'll show you basically how we go through that. I'll try just to speed up that it's not take an hour to just show you the installation, but at least have it ready. OpenELA is not deep. It's not Debian based. It's actually CentOS Fedora based. Yeah, it's not the Debian family. It's the CentOS and Fedora. So it's part of Red Hat, but it's the open source version of it. So like CentOS, it has the same kind of look at CentOS here. All right. Any more questions? All right. With with the absence of no questions, I expect obviously the WhatsApp chat also to have probably follow-up questions. That would be the end of our first introduction session. There's a question before I stop the recording. Yes. Let me just see if I can enable this mic. Allow mic. Okay. You may speak. Your mic is enabled? Or was that the accident and
Sir, I'm asking like, will
yes.
we be doing OpenLayer for the rest of the program or?
Well, no, you're doing OpenELA now for the introduction. I'll just check with Huawei if we're going to go to OpenELA HCIP, which is the advanced version of it. But there's also, remember, there's 3 tracks in this competition track. There's OpenELA, there's OpenGAS, which is a database, and then there's the developer side of it also, which is called, can't get to the name now, Kunpeng developer. Those are the 3 tracks that prepares for the competition. So what happens is that as you go through the competition, there will be times where, if you go further to the stage, you would be broken into 3 students that will compete. One will do Linux, one will do database, one will do the developer Kunpeng. And that 3 students will compete together, against other teams, other countries, and so forth. And that's basically how this track is designed here. So those are the 3, call it products or software that we'll be doing in this particular competition. Yes.
Yes,
So
sir, thank you.
you're welcome. So remember, there's cloud computing, but cloud computing is totally different. Cloud computing is the cloud, whereas this is basically focusing on operating systems, in a way, and how operating systems work, and so forth. Yeah. All right. Okay, so with that, I'll end the session. I'll see if we can have our follow-up session will be, I think I said Wednesday. And then yeah, I'll just send the link. I'll send it to Tando again, so you guys have the link. I think Wednesday we can start at, I think we can start at the same time. And then we'll probably finish this time again. Because obviously we're just going gradually through everything. You'll notice that there's not a lot of chapters in this particular thing. But again, it's just so that you understand really what each chapter is about, and to prepare well for the particular mock exam, the competition, because you will have to use this knowledge for your preparing for your vouchers when you do after the mock exam, the real exam, which is at the Pearson View Test Center. All right. So let me stop the recording now. And then, okay, there's another hand.